Welcome guys, welcome to the third video of deep learning series. The third video is all about logistic regression and perceptron. I feel that most of you guys might be aware about logistic regression if you have gone through machine learning course. Hopefully, I will make a separate video on logistic regression as well in the later videos as well. So for now, I just want to explain you. Basically, logistic regression here is one of the machine learning algorithm that basically it is used to separate. You know, for example, let's consider these are the positive points and these are the negative points. For example, basically, logistic regression is one of the machine learning algorithm that is basically used for classification purpose. Yeah, and basically it uses the concept of hyperplane to separate the positive points from the negative points. That's what logistic regression is all about, and we will discuss about it in detail in the later videos. So for now, I want to move ahead and go on the topic. Okay, so guys, basically in logistic regression, what was the scenario was basically we will have our xi, yeah, and we will predict yi hat. What is yi hat? It is basically the predicted value of yi. Yeah. What was the problem of logistic regression? Basically, for a given input xi, we have to predict yi hat, which is what is yi hat? It is a predicted value of the actual yi. And in the logistic regression, yi hat is basically equal to sigmoid function of wt transpose xi plus b. If you guys have gone through logistic regression, or if you guys have any idea on that, you guys might be aware of all of this. It is really simple, and yeah, it is one of the prerequisites to watch this video as well. So for example, if we have a data set xiyi and we have to train the model using logistic regression, we have to assess that we have unit vector w and intercept b such that w belongs to r to the power d and b belongs to r. Here we have supposed that our data set is d-dimensional. Yeah, that is, it is d-dimensional. Then definitely our unit vector will also be d-dimensional and our b will be single dimensional. That is our supposition right now. So let's move ahead. Okay, so for example, we have d-dimensional. For example, as we have considered our d-dimensional point xi, for example, yeah, that is, we have our point xi. For example, we have our point xi here. Okay, so it is d-dimensional. As suppose this is xi1, xi2, xi3, and so on. That is, xi point is d-dimensional. So how do you represent it? Using logistic regression. Our yi height, our predicted value of yi will be equivalent to sigmoid function of wt w transpose x plus b. It can be represented as, like, here we have what? X is ranging from xij. Now here, if j is going from 1 to d, what we can represent, since xi is d-dimensional, definitely our yi hat will be equivalent to sigmoid function of summation of j is equals to 1 to d wj xij plus b. Hopefully it is clear, where our xi is equals to xi1, xi2 to xid, where our w our unit vector is equivalent to w1, w2, dot 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 wd, since these are d-dimensional. Since we are considering a d-dimensional space. Hopefully it is clear. So finally, our output function is equivalent to the function of wj xij, where j is going from 1 to d. This is eventually our output in logistic regression. Now let us relate the same thing with the perceptron model. It will be really interesting to see. So let's go ahead. Now if we have to represent it, if we have to represent logistic regression in the form of neuron, so how can we represent it? Let's say as we are clear, our xi is d-dimensional. So xi, let's consider d-dimensional inputs. That's xi1, xi2, xi3 to xid. Okay, and each input have corresponding weights, that is w1, w2, w3 to wd. And as you have remembered, we have wt transpose x plus b. We have still the next weight b. So we have to consider b as an weight with input as 1. Now if we are passing it into an activation function, we will get our respective predicted yi. Now here, if the given function is sigmoid, definitely it is a logistic regression, and this is basically the diagrammatic neuron model for a logistic regression. Here basically yi hat is equals to function of w1 xi1, w2 xi2, w3 xi3, eventually to wd xid plus b, which is nothing, which is equivalent to this wi transpose wi hat is equals to function of w transpose xi plus b, which is nothing more than logistic regression. Yeah, so in this way we can represent the neuron model of logistic regression. I hope it is clear till now. So yeah. So now let us see about the Perceptron model. Perceptron model is the simplified version. It is one of the most simplified version of neural network. It was introduced in the year 1957. Look, it is similar to the logistic regression. The only difference is in the activation function. Here also we are considering the d-dimensional point along with unit vector with weight is at b. Basically here the only difference in the perceptron is the activation function, which is defined as f of xi is equals to 1 if wt transpose xi plus b is greater than 0, else it will return 0. So that is what the thing is all about. Yeah, so only the difference is in the activation function, else both the perceptron or the logistic regression are the single neuron model. What are they? They are the single neuron model. Yeah, as I have mentioned here as well, it's clearly mentioned the only difference between the logistic regression and the perceptron is the activation function. Hope it is clear. So we are near to the end. This is our conclusion, that is both the logistic regression and the perceptron, as we have seen, both are a simple single neuron model. The only difference that lies is that in their activation function. Yeah, sorry. Yeah, only this activation function is the only difference, else we can see both are the simple single neuron model. I hope it is clear till now. Till now, we have discussed the history of deep learning. We have even discussed the working of biological neural network. And right now, here we have discussed the relationship between logistic regression and perceptron. Sorry, guys, for this video, you must have at least a simple knowledge on logistic regression to know. So, yeah, that's for today. See you tomorrow.